Thank you all for coming tonight. I know it's fairly cold here. I'm from Melbourne myself. And I think that our big idea at the ARC Centre for Electromaterials Science is the creation of small devices and structures from blood cells and materials such as seaweed for the construction of little microtissues that we can study brain function. So the purpose of these structures is to allow us to understand better the function of brain as well as the dysfunction of brain that occurs in diseases such as epilepsy, Parkinson's disease, as well as schizophrenia. So, the brain is a multifunctional organ, and there is a relative dearth of knowledge in terms of where the consequences of brain function actually come from, what structures and what the origins of those functional outcomes are. And in the presence of this dearth of knowledge, we've come to early conclusions that lead us to think that perhaps brain function and its consequences come from the hand of God or miracles of nature. However, over centuries of scientific research, we've actually found that brain function arises from structural layering that layers upon itself time and time again to create the consequences of multiple functions that result in the functional aspects of what we have come to know as life. And there are those amongst us who have come to understand this layering and the nature of brain function sufficiently to be able to recreate some of the functions that have naturally arisen through millennia of evolution. And so no more poignant is our ability to create brain function than in situations where brain function is either lost or somehow compromised. And I ask you to have a look at this. So this man has Parkinson's disease.
Some quality cocktails with the right. The left just looks like the royal wave. My voice is gone. It's harder for me to get words out and speak.
So you can see the impact of this man's tremors on the way we see him.
If anyone thinks I'm faking this, I'm not.
The way that he sees himself.
Can't control the tremors and dyskinesia. The twisting in my neck is called dystonia and is really quite uncomfortable. So, as you can see, the tremors are getting much worse and I'm in quite a bit of discomfort, and I'm about to drop the remote control, which will be fun because I won't be able to turn stuff back on. So I think party time is over. Almost automatically. The power comes back on. I'm steady.
Okay, so you can see the impact that the tremors have had on his ability to interact with his environment, and in fact the way that people would see him would be totally different to the latter part of that video where he was able to turn his brain defect off, essentially, by an electrical stimulation device implanted in the brain. And this is essentially what we are trying to do in the longer term with our structures that we make out of cells from people with a neurological condition, such as epilepsy, that are embedded within material constructs to become biosynthetic implants that can then perhaps reverse the dysfunction that occurs in neurological conditions like this. So we know that there are regions of brain that are responsible for certain functions. We also know that aspects of personality are also determined from regions of the brain, and these are in fact different from people to people and define the individuality. However, when we look and drill down into the structure and the composition of the biological material that actually goes to make up the consequences of brain function, we find a highly organised, structural, layered approach that consists of numbers of different types of cells that act in concert and collectively build the function that we have come to know as our personalities, our individuality, our life in general, and our ability to interact with the environment that we live in and the universe, in fact. So this is a concept that is quite unified in nature, and you can see that there's a build-up of the ability of this gecko to go up vertical surfaces from very small structures right up to the macro scale of its toes. And this, in fact, is the approach that we've adopted with our fabrication approach that employs nanofabrication, micro, right up to macro fabrication technologies that at various stages control the structural components within these ultimate structures that we make by the addition of growth factors, by the addition of various molecules that then enable us to define an environment whereby we can get cells from the blood of an individual that we can change to these functional brain cells that can then be incorporated during this process into and added to by other processes such as fluidics, whereby we can add drugs and we can modify the environment so that we can actually model a little piece of their brain that is able to give us an insight into the way that the neural dysfunction that they have is actually occurring. And by learning about that, we can actually design personalised medicines and, in fact, personalised implants, ultimately, that will be able to replace the dysfunctional region of their brain and restore the normal function. So, at the ARC Centre, our work in regeneration of muscle and nerve over the last few years has employed a material called alginate that's derived from seaweed. And what we've been able to do here, unlike old Bootstrap Bill here, who turned into seaweed after years in Davy Jones' locker, we've actually been able to put these structures, fill them with cells, and put them in muscle and nerve, and leave behind no seaweed extract, but functional tissue instead. And from these experiments, we've been able to actually learn how to apply these sorts of materials. We've been able to learn of the limitations and the advantages of these materials and other materials for the rebuilding of regions of the CNS. And as scientists, we align our ideas with the visions of others in a way that we can actually achieve outcomes of far greater impact collectively than the sum of the individual activities. And together in these partnerships, these highly cross-disciplinary partnerships, we're actually able to integrate neurofunctionality into materials that would otherwise be inanimate pieces of food jelly. So, what does our big idea look like? And what does it mean? Pretty boring, really. So, even though it's taken a lot of time to actually develop, it's a little device here. The gel structure is placed in this outlet area here. And the whole system is made part of a fluidic system where we can influence the environment, collect metabolic output, and also read the electrical activity, in this case RAT, that then allows us to analyse the function of the tissue that we've constructed in this and read in this, this device. And we can then tailor drugs and drug regimen specifically to the deficit that is occurring. And in fact, in the case of an implant, this system allows us to ask even greater questions that relate to the earlier statements that I made about the nature of the consequences of brain function. And so imagine if a person forgot the number 4, or the concept of the number 4, because they had a piece of their brain tissue removed as a part of the brain cancer. If that memory was restored by the implantation of a piece of alginate or seaweed extract with some of their own neural cells in there, then the question arises whether the restoration of that memory through that process was actually resulting from the original tissue that was removed, or whether that memory could actually be considered a tendril of thought from a piece of seaweed brain. Thank you.